Imagine a signal from the edge of the universe, a faint whisper carried across billions of miles, reaching us not through words but through patterns only a machine could understand. In the summer of 2025, humanity stands at a crossroads. With our machines are decoding the cosmos in ways we never thought possible. Let's dive into a story that begins with a spacecraft, a record, and a question: are we truly alone? In 1977, NASA launched two probes, Voyager 1 and Voyager 2, on a mission to explore the outer planets. These twin explorers were built to photograph Jupiter's swirling storms, Saturn's delicate rings, and the icy giants Uranus and Neptune. What no one expected was that they'd outlive their original mission, venturing beyond our solar system into the vast emptiness of interstellar space. Voyager 1, now over 15 billion miles from Earth, is the farthest human-made object ever, still sending faint signals back home despite its aging systems. On board each probe is a golden record, a time capsule etched with humanity's essence, from Beethoven to traditional chants, greetings in 55 languages, and images of our world, from mountains to human faces. This record was Carl Sagan's vision, a message to any intelligent life that might find it, a cosmic postcard saying, "We exist." Fast forward to February 2025, engineers at NASA's Jet Propulsion Laboratory noticed something unusual in Voyager 1's data stream. The probe, battered by decades of cosmic radiation, had been sending garbled signals for months. But this was different. A pattern emerged, not random noise but a sequence of repeating pulses, almost like a heartbeat. Scientists fed the data into a quantum AI, a system developed in collaboration with IBM, designed to sift through cosmic noise for signs of order. What it found wasn't just order, it was a structure. The AI reconstructed a visual, a grid of interlocking geometric shapes, spirals and polygons that seemed to shift when analyzed from different angles. The lead researcher, Dr. Alina Martinez, described it as unlike anything we've seen from natural phenomena. The shapes followed mathematical rules tied to prime numbers, a universal language that any advanced civilization might recognize. This wasn't the first time Voyager's data raised eyebrows. In 2024, Voyager 2, trailing its sibling by a few billion miles, sent back readings that puzzled astronomers. Buried in what was thought to be background radiation was a faint signal, a series of coordinates pointing to a region called the Eridanus supervoid, a massive empty patch in the universe, roughly a billion light-years across. Unlike the Boat's void, which holds a few lonely galaxies, the Eridanus supervoid is eerily barren, a cosmic desert that defies our models of how galaxies should cluster. The coordinates from Voyager 2 weren't a map to a star or planet but to this void center, a place where nothing should exist. Theorists speculated, could this be a marker, a beacon left by something or someone using the void's emptiness as a canvas? The golden records on both Voyagers carry more than just greetings. They include instructions, etched in symbols, for how to play the record's contents. The hope was that an alien civilization would decipher the code, spin the disk, and hear humanity's voice. But what if the records weren't just a message but an invitation? Carl Sagan himself called them a bottle cast into the cosmic ocean. The probes are drifting through space with no specific destination, their paths unlikely to cross any star system for millions of years. Yet, the precision of the signals detected in 2025 suggests something might have noticed. The question isn't just whether someone found the record, it's whether we were meant to get a reply. Let's shift gears to a man who's spent his life pondering these questions, Dr. Avi Loeb, the Harvard astrophysicist known for his bold ideas about extraterrestrial life. Loeb has argued that the universe is teeming with possibilities for intelligent civilizations. With trillions of planets in our galaxy alone, the odds of Earth being the only home to life are vanishingly small. He points to the Fermi paradox, the puzzle of why we haven't seen signs of alien civilizations despite the universe's vastness. Loeb's answer is that we might be looking in the wrong places or with the wrong tools. He suggests advanced civilizations could communicate using methods we're only beginning to grasp, like neutrinos, gravitational waves, or even encoded light pulses that our telescopes mistake for natural phenomena. Loeb's latest work focuses on a strange object that passed through our solar system in 2017, Oumuamua, the first confirmed interstellar visitor. Unlike any comet or asteroid we've seen, it had no tail, an odd cigar-like shape, and accelerated in ways that defied simple gravitational explanations. Loeb proposed it could be an artifact probe or even debris from an alien craft. Critics dismiss this as speculative, but in 2025, new data from the James Webb Space Telescope reignited the debate. The telescope captured faint infrared signatures from Oumuamua's last known position, suggesting it might have left a trail of microscopic particles, possibly synthetic in origin. Loeb called it a breadcrumb from another world, urging scientists to rethink how we search for extraterrestrial technology back on Earth. Another discovery is shaking the scientific community. In 2023, Japan's Hayabusa 2 mission returned samples from the asteroid Ryugu, a rocky relic from the solar Systems early days. Analysis in 2025 revealed something startling. Traces of amino acids and complex organic molecules, the building blocks of life, but arranged in patterns that hint at artificial synthesis. These molecules didn't match any known biological processes. On Earth, Dr. Sanae Takahashi, leading the analysis, noted that the structures resembled self-replicating polymers, a concept explored in theoretical nanotech but never observed in nature. Could Ryugu hold clues to a long-lost experiment, perhaps one seeded by an intelligence billions of years ago? The idea of life beyond Earth isn't new, but our ability to probe it is. Enter quantum computing, a technology that's rewriting what's possible. Unlike traditional computers that process bits as zeros or ones, quantum computers use qubits, which can exist in multiple states at once, thanks to quantum mechanics. This allows them to tackle problems that would take a digital computer billions of years to solve. In 2025, China's Zhejiang 3.0 quantum computer achieved a milestone. It simulated the behavior of a hypothetical alien molecule, one theorized to exist in the atmospheres of exoplanets. The simulation revealed properties that could support life unlike anything on Earth, sparking debate about whether we're on the cusp of decoding extraterrestrial chemistry. Quantum computers aren't just for chemistry, they're transforming how we listen to the cosmos. The Square Kilometre Array, a massive radio telescope project spanning Australia and South Africa, began operations in 2024. Paired with quantum processors, it's scanning the skies for signals that older systems might have missed. In March 2025, the array detected a series of fast radio bursts, intense flashes of energy from deep space, repeating in a pattern tied to the Fibonacci sequence. Natural phenomena like pulsars produce random bursts, but this sequence suggested intent. Dr. Priya Anand, a lead astronomer, said, "It's like someone's sending us a math problem." The burst's origin: a distant galaxy, 3 billion light-years away, near the edge of a void not unlike Eridanus. Let's talk about the Moon, our closest neighbor, which is turning out to be more mysterious than we thought. India's Chandrayaan-3 mission, which landed near the lunar South Pole in 2023, sent back seismic data in 2025 that raised questions. Sensors detected vibrations from beneath the surface, suggesting cavities or voids with unnaturally smooth boundaries. These weren't the jagged cracks of natural geology, but shapes that hinted at structure: hexagons, cylinders, even traces of lattice-like formations. Geologist Dr. Arjun Patel speculated that these could be remnants of ancient volcanic processes. But others, including Loeb, wonder if they point to something artificial, perhaps left by a civilization that visited the Moon eons ago. The lunar South Pole is also rich in water ice, a resource that could fuel a new space race. Water isn't just for drinking, it can be split into hydrogen and oxygen for rocket fuel, making the Moon a potential gas station for deep space missions. In 2025, China announced plans for a lunar base near the same region, followed by NASA and private companies like SpaceX. The competition is heating up, but so are concerns. If the Moon holds artifacts or resources tied to an ancient intelligence, who has the right to claim them? Loeb has called for a global treaty to ensure cooperation, warning that unchecked exploitation could erase clues to our cosmic origins. Now, let's consider artificial intelligence, the force driving many of these discoveries. AI isn't just crunching numbers, it's reshaping how we understand the universe. In 2025, DeepMind's Alpha Cosmos, a specialized AI for astrophysics, analyzed decades of radio telescope data and found patterns missed by human researchers. One discovery was a faint signal from the direction of Proxima Centauri, our nearest stellar neighbor. The signal, a series of modulated waves, didn't match any known natural source. While it's not proof of aliens, it's the strongest candidate. Yet for a technosignature, a sign of intelligent activity. The AI's ability to filter noise and detect anomalies is pushing the search for extraterrestrial intelligence, or SETI, into a new era. But AI's power comes with risks. Experts like Dr. Emily Chen, a former OpenAI researcher, warned that artificial general intelligence AI that rivals human reasoning could emerge by 2027. A 2025 report from the AI Safety Institute estimates a 15% chance that unchecked AGI could disrupt global systems. From economies to defense networks, the same AI decoding cosmic signals could, if mismanaged, outpace our ability to control it. Chen advocates for cosmic guardrails, protocols to ensure AI serves humanity's quest for knowledge without becoming a liability. Let's zoom out to the biggest mystery of all, the Greater This gravitational anomaly, located 250 million light-years away, is pulling our galaxy and thousands of others toward it at 2 million miles per hour. What's causing it? No one knows. It lies in the zone of avoidance, a region obscured by the Milky Way's dust. In 2025, the European Space Agency's Gaia telescope mapped the motions of stars near the Great Attractor, revealing a structure denser than any known supercluster. Some theorize it's a massive black hole, others a cosmic string, a hypothetical fold in spacetime. Dr. Marco Silva, a Gaia researcher, says, "It's like the universe has a hidden engine we can't see. Could it be natural, or is it a sign of something manipulating the fabric of space itself?" The universe is full of voids, too, like the Eridanus supervoid. These empty spaces challenge our understanding of cosmic evolution. After the Big Bang, matter clumped into galaxies and clusters, but voids grew where matter was scarce. The Eridanus supervoid, discovered in 2004, is so large it shouldn't exist under standard models. Its emptiness suggests something disrupted, the normal distribution of matter, perhaps a quantum event in the early universe, or, as fringe theories propose, an artificial clearing. The Voyager 2 signal pointing to this void adds intrigue. Was it a coincidence, or is something using these voids as cosmic signposts? Back on Earth, we're grappling with threats closer to home. Asteroids pose a real danger, with thousands of near-Earth objects tracked by NASA's Planetary Defense Program. In 2025, a 200-meter asteroid dubbed 2025 XF12 was flagged as a potential risk, with a 0.02% chance of hitting Earth in 2033, while the odds are low. The impact would release energy equivalent to 50 megatons of TNT, enough to devastate a continent. Technologies like kinetic impact, as tested by NASA's DART mission in 2022, offer hope, but scaling them up requires global investment. Dr. Loeb emphasizes that asteroids don't respect borders, urging nations to unite in defense efforts. Let's circle back to the golden records. What if they've been found? The signals from Voyager 1 and 2, the patterns in fast radio bursts, the lunar voids all hint at a universe that's not just vast but active. The records were meant to say, "We're here." But what if something replied, not with words, but with math, shapes, and coordinates? The AI decoding these signals is our bridge to understanding, but it's also a reminder of our limits. We're infants in a cosmic playground, sending messages without fully grasping who might answer. Quantum computing could be the key to unlocking these mysteries. In 2025, Google's Sycamore X solved a cryptographic puzzle that would have taken a supercomputer a million years. This power could decrypt signals we've overlooked or simulate environments where alien life might thrive. But it also raises a question. If we decode an alien message, are we ready for what it says? Dr. Martinez, who analyzed Voyager's signal, warns that the message might not be for us, but for our machines. A test of whether our technology is advanced enough to join a larger conversation. The moon, too, holds secrets. Chandrila data suggests the lunar South Pole isn't just a resource hub but a geological puzzle. The voids detected could be natural, formed by ancient lava tubes, but their geometric precision invites speculation. Could they be relics of a long-gone visitor, or are we projecting patterns onto random data? The race to mine the moon's ice and minerals is accelerating, but so is the need to preserve its scientific value. If we dig too fast, we might destroy evidence of our cosmic past. AI's role in all this can't be overstated. Alpha Cosmos and similar systems are finding signals humans missed, but they're also evolving. In 2025, an AI developed by XAI called Starseeker predicted the location of a new exoplanet based on gravitational wobbles in a distant star system. The planet, dubbed EOS-1, has conditions that could support liquid water. This discovery, made without human intervention, shows AI potential to lead the search for life. But it also underscores the need for oversight. If AI misinterprets a signal or, worse, acts on it independently, the consequences could be profound. The Great Attractor pulls us toward the unknown, both literally and metaphorically. Its mystery reminds us that the universe is full of forces we don't understand. The Gaia telescope's data suggests it's not just a cluster but a dynamic system, possibly shaped by unseen physics. Some speculate it could be a gateway, a region where space-time behaves differently. If we ever reach it, perhaps with quantum-powered probes, what will we find? A natural phenomenon, or something engineered by minds far beyond ours? Asteroids, meanwhile, keep us grounded. The 2025 XF1 to scare prompted NASA to fast-track a new deflection mission, set for 2027. The plan involves a swarm of small satellites equipped with lasers to nudge the asteroid off course. It's a test of our ability to protect Earth, but also a reminder of our fragility. A single rock could undo centuries of progress, making the search for cosmic neighbors feel both urgent and humbling. The signals, the voids, the AI, the moon, all these threads weave a tapestry of a universe that's alive with possibility. The Voyager probes, now silent ambassadors, carry our hopes into the dark. Their golden records, spinning through the void, might be our first hello to something greater. But the replies we're starting to hear, decoded by machines we built, suggest we're not just sending messages, we're receiving them. The question is, are we ready to listen? The Eridanus supervoid looms as a silent challenge. Its emptiness could be a quirk of cosmic evolution or a sign of something deliberate. The fast radio bursts, the lunar voids, the Oumuamua enigma, they all point to a universe that's not just a backdrop but a stage. Our quantum computers and AI are giving us the tools to read the script, but we're still learning the language. Dr. Loeb puts it best. We're not alone. but we might be too young to understand who's out there. As we stand on the brink of 2026, the pace of discovery is accelerating. Quantum computers are solving problems once thought impossible. AI is scanning the skies with unprecedented precision. The moon is becoming a battleground for resources and knowledge. And somewhere, billions of miles away, Voyager 1 and 2 drift on, carrying our voice into the unknown. The signals they've sent back, the patterns in the void, the mysteries on our doorstep, they all ask the same question. What happens when the universe answers? This is our moment. We're building machines that can talk to the stars, but we're also learning how little we know. The golden records were a bold gesture, a declaration of our existence. Now as we decode signals from the cosmos, we face a choice: to listen, to learn, and to prepare. The universe is vast, but it's not empty. Something's out there, and it's time we paid attention.